Welcome to qnawire.
This is question 574. We have two blocks, M1 and M2, connected by this pulley, and they're sitting on this wedge. And we are asked, what must the mass of M2 be in this hanging block if it's going to descend 12 meters in 3 seconds after the system is released? So here's the information that we're given. We want to start here by setting up sum of the forces equals the mass times acceleration. So let's think of this whole system as just one thing here. So we're going to consider the plus x direction, or just the positive direction, as being along this line going up and then down, because the system is going to be accelerating down over here. So that's going to be our positive direction. So let's think about the positive forces acting on this whole system here. The only thing that's going to be pulling these two blocks is going to be gravity. So our force of gravity is going to be m2 times g. That's going to be what's pulling this whole thing down. And then opposing that, we're going to have the gravitational force from this first block. So that's going to be m1 times g. But then this is going to be, we want just the component in the y direction here. So that's going to be multiplied by the sine of this angle alpha. And then we also have a frictional force here. So the frictional force is going to be equal to the coefficient of friction times the normal force. And the normal force here, since we just have gravity pulling this down, the normal force is going to be mg and now cosine of alpha. So these are the forces acting on the system. And now this whole system is going to be moving together. So the total mass will be m1 plus m2, and that's going to be multiplied by the acceleration. So now we need to figure out what the acceleration is. Remember, we're told that the system moves 12 meters in 3 seconds. So we can use our kinematic equation, d equals v0 times t plus 1/2 a t squared. Now the system is starting from rest, so v0 is 0. So this whole term is going to be just 0. And we know what d is, and we know what t is, so we just want to solve this for a. So we're going to get 2d when we multiply both sides by 2, and then divided by t squared, that's going to be our a. So now plugging in d equals 12 and t equals 3, we should end up with a equal to 2.67 meters per second squared. So now we can go back to our formula up here. And let's just check that we know everything. So we're solving for m2. We know g is 9.8. We have m1, we have alpha, we have mu k, and now we also have a. So let's, we see m2 show up a few different times here. So let's just simplify this and group these over so we can solve for solve for m2. So I'm going to pull out this factor of a here, and then move this m2 to the other side. So we're going to end up with this over here. And now I can pull out this factor of m2. So that's going to give me this over here. And now I want to move all of these other terms to the right. Let's do this on a new line. So I'm going to add in these two terms to this other side over here, so that I now have m2 on its own, and then divide by g minus a, so that I have this whole thing like that. And so now all we have to do is plug in everything that we know here, and we should end up with m2 equal to 36.1 kilograms.